Hello everyone, welcome to Geometry Lesson 3.1, Relationships Between Lines. In this lesson, we'll get to see all kinds of different lines and how they can relate to each other and a lot of different ways we can classify pairs of lines. So let's get started. First we have parallel lines. I'm guessing you know what these are, but the actual geometric definition of parallel lines is that they're coplanar lines that never intersect. Most of that definition is probably pretty obvious to you, lines that never intersect. So the traditional example of parallel lines is railroad tracks. But let's think about this word coplanar, because that's going to come up later. Coplanar, remember, co means same, and then planar means plane. So these are lines that are on the same plane. So if I wanted to sketch a pair of parallel lines, first I need to draw a plane. That's this quadrilateral figure in the back here. And in that plane I need to draw my two lines. To mark that lines are parallel, we use these little arrows inside the line themselves. Next, let's look at perpendicular lines, kind of the total opposite of parallel. Perpendicular lines are just lines that intersect to form right angles. So I've got my two lines here, and their intersection is a right angle or 90 degrees. Here comes one that might be new to you, skew lines. Skew lines are non-coplanar lines that never intersect. Now compare this definition to the definition of parallel lines, and you'll see why that coplanar word was so important. Skew lines never intersect, just like parallel lines, but the difference is that these lines are non-coplanar. They can't be in the same plane. So when I'm drawing a picture of this, I'll start by drawing a picture of my plane and a line in that plane, but then the other line is going to be outside of that plane so that it looks like in 2 dimensions those two lines would cross, but in 3 dimensions they're not going to. It might be a little easier if we look at a picture of a box. So if I draw this box on here, maybe this is a Kleenex box. So I'm going to choose this line that runs along the front top corner of the box. And then the other line that I'm going to choose is this one that runs along the bottom right edge. These two lines, even though they overlap in 2 dimensions, if you think about this as being a 3-dimensional object, those two lines are never going to intersect. If you don't believe me, try taking a ruler and laying it across that top edge of a Kleenex box and lay another ruler along the bottom edge that I've highlighted, and you'll see that those two are never going to cross. Our next term is parallel planes. And this is just like parallel lines, but with planes. So parallel planes are planes that never intersect. Back up to my 3-dimensional figure up here, I could use the top and the bottom planes for this example. My last term for this section is a line perpendicular to a plane. A line that's perpendicular to a plane is just a line that intersects a plane at a right angle. So to draw this, I want to first draw a picture of my plane, and then I want to draw a line intersecting that plane, just like we did in section 1.4, and I'm going to mark that intersection with a right angle marking. Now that we've got these terms down, let's see if you can identify a couple of these. So in my diagram here, I have 3 lines that are all intersected by line Q. So first I want to name 2 parallel lines. Parallel lines, remember, are 2 coplanar lines that never intersect. So lines M and N look like they're never going to meet, so I can say that those two are parallel. So there aren't any markings in this picture that tell me that lines M and N are parallel. So in this part, I kind of just have to say, well, I think these two are parallel, and I kind of have to go with what they look like. But in a couple sections, we're going to learn how to use those 2 right angle markings to actually prove that these 2 lines are parallel. But for now, we just have to base everything on look. Next, name 2 perpendicular lines. Perpendicular lines, remember, means that they meet at a right angle. On here I have 2 right angle markings, so I know that lines Q and M are perpendicular, and lines Q and N are perpendicular also. Okay, so in our next example here, we have this 3-dimensional figure. It's another box, if you want, a rectangular prism. And I need to name each of the following pairs on here. So this will give us some really good practice with recognizing and naming a bunch of different figures. So parallel lines first, 2 coplanar lines that never intersect. So let's start with line FG on the back corner here. And I want to pick a line that would be parallel to. I actually have 3 choices. I could choose line CB up on the top. I could use line EH on the bottom. Or the tricky one is line AD that goes across that front diagonally. And I'm just going to pick line EH. Next we have to find perpendicular lines. Perpendicular lines, remember, are marked with that right angle bracket, and I have 3 of those markings in this diagram, so I just need to pick a pair of lines that meets at that marking. So if I work with this one on the top right, I'm going to use line AB and line AD. Parallel planes, there are three different pairs that would work for this one. I'm going to choose the top plane here and the bottom one down here. And remember, when you're naming planes, you need to use 3 points that are on that plane. So for the bottom plane, I could call that plane EHG, and the top plane I could call plane ABC. Next, we need skew lines. So these are a little tricky, but this diagram might make it a little easier to see this. So skew lines, remember, are non-coplanar lines that never intersect. So I have to pick two lines that aren't in the same plane. So I'm going to start with line EF. Now I need any line that won't intersect that and isn't in the same plane. So basically something that's not parallel to it. So in this diagram I have a few different options. I could use line BC, I could use line AD, I could use line AH, and I could also use line BG. So I'll just choose line BG for this example. Next, I need to name a line that's perpendicular to plane EHG. So we'll highlight plane EHG first, that's this bottom one, and then I have that right angle marking on the front right corner there, so that would be line AH. Alright, now let's do a couple problem solving examples. Our first example says, the given line markings show how the roads are related to one another. Name a pair of parallel lines. So here's kind of a time we would see parallel lines in the real world. I have a few different options here. I could use these two vertical lines, line AM and line BO, or I could go horizontally and choose any one of these three lines. I'm actually going to choose a couple horizontal lines, so we'll use line CD, that's that top one, and line OE, that's the one in the middle there. We have special notation we can use when we're trying to say that something is parallel. When you put those two lines in the middle there, that denotes that those lines are parallel. In our next example, we're asked to use the markings in the diagram to see if line PR is perpendicular to line PN. That upside down T in the middle is the symbol that we use for perpendicular, just like the symbol we just used for parallel. Remember those red arrows down there show that those two lines are parallel. So my question is line PR perpendicular to line PN? So we just have to answer our question. That right angle marking there is actually between lines PN and PQ. So those two lines would be perpendicular, but lines PR and PN aren't. That's all for lesson 3.1. Remember, you can go back and rewatch any parts of the video if there was something that you didn't understand. Thanks for joining me, and happy hypothesizing.